Now, sequence of program when subroutine is called and executed. So first see the how sequence is. So here in main program we are going to write this call instruction. Whenever call instruction is executed, it will shift to the some memory location. The sequence of memory, sequence of program counter execution, sequence of program execution is shifted to another memory locations where some routines will be written and all those. So here first, when call instruction is executed, say call instruction. When call instruction is executed, this a call is a 3-byte instruction. One is opcode and remaining two is a 16-bit address, lower order address and higher order address for one location. So total 3 bytes are required for to execute the call instruction. And first sequence of execution is the contents of every time after execution of any instruction, the program counter is incremented by 1. Program counter is incremented by length. See, if call instruction is executed, this program counter is incremented by why? Because 3 times. Incremented by 3. Incremented by 3 locations or 3 times. 3 locations. Why? Because this is a 3-byte instruction. And next, and second point, PC is incremented and stock pointer is also incremented by 1. Stock pointer becomes stock pointer plus 1. Here PC plus 3. Next, in third, the lower order address. Lower order. Here, first program counter is there. Program counter holds the address of program counter holds the address of sequence call instruction address, where now program counter is incremented by 3 times, stock pointer is incremented by 1, and when stock pointer incremented by the lower order address, here this PCL lower order address of program counter is pushed onto the stock pointer. And the fourth one is again once a lower order address of stock program counter is pushed onto the stock, again stock pointer is incremented by 1. Stock pointer is incremented by 1. After that, in fifth instruction, higher order address of program counter, that is PCH, will move to the stock again. Stack SP stock pointer. And next sixth one is the sixth step is the second byte of instruction is loaded to PCH and third byte of instruction is loaded to PCL, like that, PCH and PCL. Now the instruction at PC is executed. Instruction at PC is executed. The last instruction of called subroutine must be written in section. After execution of called subroutine, address of stock is loaded into PC, and stock subroutine may therefore begin anywhere in the full 64 kilobyte of program memory address space, and no flags are affected here. So to understand this concept very clearly, first we'll understand with the help of diagram. I stop here and I'll draw the diagram first. Look at this program here. This is a main program. We wrote here main program. This is a main program. The main program starts at 2000 location, and where it exactly at a 2004 location, the L call, long call is executed. Once this executed, program counter is incremented by 3 times, 1, 2 and 3 times. Now, what is the program counter is holds the address of 2007. First, this 2007 and before 2007, and here L call 70 and 60. This is 607 lower order address of subroutine program and higher order address of subroutine program, where we are mentioning the address of subroutine program in the call instruction itself. So therefore, means call instruction L call 6070. This instruction. This is the instruction which we written in the main program. Now, after execution of this program, 2004, here opcode will be opcode of operation code of L call will be stored here, and this is lower order address X after stored in 2005, and higher order address will be stored in 60. And the subroutine program here. So here main program starts at 2000 locations, and subroutine, we know that subroutine will be stayed at 07 location at any instant of time at the reset condition. Okay. Next, here at 2004 location, the program counter main program finds the sequence of so it finds the subroutine sequence. So it encounters the subroutine call instruction at 2004 location in the main program. Immediately program counter is loaded with starting address. Once this instruction is executed, the program counter is loaded with PC is loaded with 6070, which is a subroutine address. 6070 and return address of program counter. See, after execution of this subroutine program, where exactly from where the program counter sequence is shifting from 2007 to 6070. After execution of all this subroutine program, whenever return instruction is executed, again the program counter should load with 2007 address. So therefore, when program counter sequence is changing from 2007 to 6070, this address has to be stored in stock pointer. So when subroutine encounters in a main program, immediately program counter is loaded with subroutine address, starting address of the subroutine, which is a 6070, and return address 2007H is loaded onto the stock. This 2007 is loaded onto the stock. Initially, say whenever means we are pushing the address of program counter address is pushing onto the stock. So therefore, first stock pointer should be incremented by 1 while pushing the data onto the stock. So it points to 08 locations. In 08 locations, this lower order address will be stored. Lower order address will be stored at 2007. Next, once lower order address is stored in the stock, again stock pointer is incremented by and it points to 9. Now higher order address of the program counter will be stored in here. Stored. Now the return address of program counter is pushed onto the stock. Now the program counter starting address is loaded with a starting address of here. Last address of program counter is pushed onto the stock, and initial address of subroutine is loaded onto the program counter. Now program counter executes this instruction sequentially. Whenever the return instruction is executed, again pop address of the main program from the stack. The pop instruction will be executed. Now the sub program at a location 6070 is starts executed. Whenever controller encounters the return instruction in the subroutine program, it will return back to the return address 2007 of the main program. At same time, program counter contents becomes 2007H. At the control and controller starts executing the remaining main program. Here, this program counter, while call instruction is executed, program counter is loaded with initial address of the subroutine, and the present program state program controller address is pushed onto the stop at 08 and 09 locations. Lower order address of program counter main program and higher order address of lost program counter address is pushed onto the stop, and after once pushing is completed, now program counter executes the subroutine program. Whenever program counter encounters the otherwise controller encounters the return instruction in the subroutine program, it collects, say, whenever return instruction is executed, the the controller pops the address of lost address of program counters of main program, and which is present in stock point. Right? Therefore, while pop instruction, first initially it pops the data onto the stock, onto the register, onto the program counter. So that is PC. This is PC. This loaded into PCH register of the program counter, and once PCH is loaded with the 09 locations, next stock pointer will be decremented by 1. Now the stock pointer will shows the 8 locations. Now this 8, the contents of stack pointer whose address is 08 and those contents are 07. These contents are loaded onto the PCL program counter lower order program counter. Now the post PCH and PCH combinedly will forms 2007, which is the lost address when call instruction is executed, when a program counter is shifting from its sequence from main program to the subroutine program. So previously, see, while executing call instruction, it was of 2004, 5, 6, and next program counter should jump to the next instructions to be executed. So this instruction has to be this address has to be stored in stock pointer, and this stock pointer this address again retrieved whenever controller finds return instruction in the subroutine program, and it pops a previous program counter address, and from where our main program sequence and starts continuous execution like this, and somewhere it is end. This is all about how our program sequence changes whenever subroutine, whenever call instruction is executed in main program, and how our program counter address is pushed onto the stock, and how program counter address is popped onto the stock whenever the return instruction is encounters the return instruction in the subroutine program. And next, there are different types of subroutines are there. Different types of subroutines. Subroutines. This one, first one is multiple calling subroutine. Multiple calling subroutine. And second one is nesting of subroutine, nested subroutines, nested subroutines. And third one is multiple ending subroutines. Multiple ending subroutines. And see, first we'll see one by one multiple calling subroutines. In multiple calling subroutines, here this is a main program. Assume this is the main program. Multiple calling subroutine. Here one call instruction is there. First, we are calling a subroutine program. Somewhere here it is subroutine program will be there. Here a return instruction. Here first another after sometimes again we called subroutine program second time. After sometimes again we called a subroutine program third time, and so on like this. We can call a multiple number of times. So therefore, whenever call instruction call first subroutine first call instruction is executed, the program counter is loaded with starting address of this subroutine. Whenever return instruction is executed, whenever call instruction is executed in a main program, program counter is loaded with the starting address of subroutine, and the next instruction in the next instruction in the main program whose address is pushed onto the stack. And whenever this after execution of this subroutine program, this return in whenever controller encounters the return instruction in the subroutine program, uh, this stock pointer address, the last address of program counter which is present on stock has to popped up first, popped onto the program counter PC H and PC help, and these data again from this onwards another program sequence executes as whenever call instruction is executed. When call instruction is executed again, again program counter is loaded with the initial address of this initial address. The program counter is loaded with the initial address of again subroutine program. This is a subroutine program. Again it jumps whenever return call is it jumps to main program and again continues like this. After third after call instruction is executed a third time, say like this, whenever call is executed, program counter is loaded with the initial address of program counter, again it returns back. This is the concept of multiple calling subroutine. We are calling subroutine multiple times whenever it is required. And nested subroutine means here we consider this is a main program. Main program is there. Here we call some subroutine program, and our program counter is jumps to the subroutine address here, subroutine program, initial address of the subroutine, and executes its program. In between, again call instruction is there. So therefore, again program counter shifts to subroutine 2 program. This is subroutine 1 and this is subroutine 2 program. Again it executes like this. Again it comes back to return subroutine 1 and it executes. After execution, return instruction is encountered by the controller. Now controller again here the return address is jumps to the main program of main program. So here we called subroutine. Inside a subroutine, another call instruction is there. These kind of techniques is called as a nested subroutines. Subroutines and inside another subroutine will be there. This is subroutine concept. And last one is multiple ending subroutines. In multiple ending subroutines, what happens is I'll take this color. Here, consider this is a main program. Some way we called a subroutine program in between this main program, and it jumps to subroutine program. This is subroutine program, and this is a main program. Now program counter is loaded with the initial address of subroutine, and it executes. In between, some conditional returns will be there, like return on carry, then it jumps to return on carry. If carry is present, then it automatically returns to the main program. If no carry, again it executes subroutine instructions, subroutine programs, and in between there is a some ORZ, a return on 0. So again it jumps to return address. So therefore, multiple ending subroutines will be in subroutine programs. If their condition satisfies, it jumps to the main program. Return on carry, return on 0. If return on carry and return on 0 is not executed, then it further executes the remaining instructions in subroutine program. Again, if whenever return instruction is there, again it jumps to the main program again. See here, this is multiple ending. So in subroutine program, if the condition is exists, then again it comes back to the main program. If return on carry, if carry is present, then automatically it returns to the main program. If this condition is not satisfied, then again executes this following instructions. Whenever this ORZ is come, if return on 0, if 0 is there, then it should come to the main program. Otherwise, again it continues remaining programs. Whenever it encounters the return instructions, then it again returns to main program. See, this is all about subroutine programs and push and pop operations I explained in a previous video. Now it is what is the sequence of program counter sequence when call instruction is executed and return instruction is executed, and where the lost address of program counter is stored onto the stock, and how it can be pushed onto the stock and how it can be popped onto the stock, and what are the different types of subroutines will be there. This is a multiple calling, we can call multiple times from main program, and same subroutine program we can call many number of times and as many times as we want. And nested subroutine is a subroutine inside another subroutine will be there. Whereas in a multiple ending, in the subroutine programs, there is a conditional returns will be there. If condition is satisfied, it jumps to the main program. Otherwise, it continues. If another condition is satisfied, it jumps to the main program, and then continues. Like that, there are these three different techniques will be there. Thank you so much.